Friends, welcome to Bank Exam Cafe, and in today's episode we are going to discuss 2 marks questions from the topic linear equations in 2 variables. Friends, this is the part 2 and we have uploaded first part in which we have already discussed that what is the trend of asking the questions from the linear equations in 2 variables. I request you to watch that part also. Now let us see the first question of today's episode. Here is the question on the screen, that find the value or values of k for which the pair of linear equations kx plus y is equal to k square and x plus ky is equal to 1 have infinitely many solutions. Friends, here the given equations are kx plus y is equal to k square, and the another equation is that x plus ky which is equal to 1, and you have to find the value of k such that the pair of linear equations will have infinitely many solutions. We know that for infinitely many solutions, the condition is that a1 upon a2 that is equal to b1 upon b2 that is equal to c1 upon c2. If this condition is satisfied, then we say that the pair of linear equations have infinitely many solutions. So put these values a1 and a2 are the coefficients of x, so it will be k upon 1. So it will be k upon 1, which is equal to b1 upon b2. b1 that is the coefficient of y, so it will be 1 upon k, 1 upon k, and which is equal to c1 upon c2 is a ratio of the constant terms, so it will be k square upon 1. Now these 3 ratios are equal, so first we will take the first 2 ratios. So for k upon 1 that is equal to 1 upon k, from this we will get k square that is equal to 1, cross multiply, so k square that is equal to 1, and therefore k is equal to square root of both the sides, it will be plus minus 1. Highlight this because you have got the value of k here, that is plus minus 1. Here you have to consider the both values. Generally we take the positive value, and therefore most of the time here we commit the mistake that we just take the square root of 1 as plus 1, but don't do so. As much as the quadratic equation is concerned, always take the both signs, that is positive and negative, whenever you take the square root of any number. Now for this ratio, for 1 upon k that is equal to k square plus 1. Now cross multiply this, so it will be k cube which is equal to 1, and therefore taking cube root of both the sides, so k will be equal to 1. So after solving these pairs we get k is equal to 1, and with this pair we get k is equal to plus or minus 1, and therefore finally your answer will be that k should be equal to plus or minus 1. Then the given pair of linear equations will have infinitely many solutions. Now move to the second question. Without drawing the graph, find out the lines representing the following pair of linear equations intersect at a point, are parallel or coincident. So here without plotting we have to decide that whether the given pair of linear equations intersect at a point or are parallel or coincident, and the given equations are 18x plus minus 7y which is equal to 24, and this will be 9 by 5 minus 7 by 10y minus 7 by 10y, that is equal to 9 by 10. So here these two equations are there, and so first we will find a1 upon a2, because we have to find whether the lines intersect at a point, or the lines are parallel, or the lines are coincident. So a1 upon a2, that is 18 by 9 by 5, 18 upon 9 by 5. So this will be 18 multiplied by 5 by 9. 9 ones are 9, 9 twos are 18, and 2 fives are 10. So a1 upon a2, that is equal to 10. Similarly, find b1 upon b2, and b1 upon b2 is equal to what? Minus 7 upon minus 7 by 10. So it will be plus 7 upon 7 by 10. So which is equal to 7 into, take a reciprocal of this denominator, so it will be 10 by 7. 7 and 7 will get cancelled, and which is equal to 10. Now move to the next, that is c1 upon c2. c1 upon c2, that is the ratio of the constant terms, so it will be 24 upon 9 by 10. 9 by 10. So which is equal to 24 upon 1 multiplied by, take a reciprocal of this, that is 10 by 9. So 3 3s are 9, 3 8s are 24, and which is equal to 80 by 3. And so here we see that a1 upon a2 is 10, b1 upon b2 is 10, and c1 upon c2 is 80 by 3, and therefore we can write that a1 upon a2, that is equal to b1 upon b2, because these two ratios are equal, but the third ratio, that is the ratio of the constant terms, is not equal, so is not equal to c1 upon c2. And if a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, then we know that the lines are parallel, and therefore the lines are parallel. Now move to the next question. Question is that for what value of a and b for which the following pair of linear equations has infinitely many solutions. The two equations are 2x plus 3y is equal to 7, and the another equation is a plus b, close the bracket, into x plus into bracket 2a minus b, close the bracket, into y, that is equal to 21. And we have to find the value of a and b such that the given pair of linear equations will have infinitely many solutions. And now here you see that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. This is the condition for the infinitely many solution, or you may say that coincident lines. So for infinitely many solutions, the condition is that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Now take the ratios. a1 upon a2 is the ratio of the coefficients of x, so it will be 2 upon a plus b. That is equal to b1 upon b2, that is the ratio of the coefficients of y, that is 3 upon 2a minus b, which is equal to c1 upon c2, that is the coefficient of constant terms, that is 7 by 21. Now here we see that this first and third we will equate. So for 2 upon a plus b, that is equal to 7 upon 21. So 7 ones are 7, 7 threes are 21, so 3 twos are 6, and so a plus b, that is equal to 6. Let this be equation number 1. Now we will take this second and the third. So for 3 upon 2a minus b, that is equal to 7 by 21. 7 1s are 7, 7 3s are 21, 3 3s are 9, and therefore you will get it as 2a minus b, that is equal to 9. So 2a minus b, that is equal to 9. So let this be equation number 2. This is the equation number 2. A plus b is equal to 6, and solve this equation number 1 and 2. Solving equation 1 and 2. If you solve this equation 1 and 2, you will get it as, so if you add this b and b will get cancelled, and 2a plus a, that will be 3a, which is equal to 9 plus 6, that will be 15. So it is 3 1s are 3, 3 5s are 15, and so a is equal to 5. So here we have got the value of a. Highlight this step, that is important. Now put the value of a in equation number 1. So putting in equation, put in equation 1, then we will get, here we will put the value of a as 5. So it will be 5 plus b, that is equal to 6, and so b is equal to, take 5 to this side, so it will be 6 minus 5, that will be 1. So we have got the value of b as 1. Highlight this step, and so at the end write the answer that the required values of a and b are 5 and 1. And now let us see the next question. The question is that find the value of a and b for which the following system of linear equations has infinite number of solutions. The equations are a plus b, close the bracket, into x minus twice of by, which is equal to 5a plus 2b plus 1. And the second equation is that 3x minus y, which is equal to 14. And now for infinitely many solutions, the condition is that all the three ratios should be equal, and therefore the condition is that a1 upon a2, that is equal to b1 upon b2, that is equal to c1 upon c2. And if this condition is satisfied, then we say that the given pair of linear equations has infinite number of solutions. So a1 upon a2, this ratio is the ratio of the coefficients of x, and so it will be a plus b upon 3, which is equal to b1 upon b2, that is the coefficients of y, so it will be minus 2b upon minus 1, that will be 2b upon 1, because minus minus will become plus. So which is equal to c1 upon c2 is the ratio of the constant terms. So this is the constant term. So 5a plus 2b plus 1 upon 14. Now we will take this first and the second. So for a plus b upon 3, that is equal to 2b, correct? And so here take 3 to this side, so it will be 3 2s are 6, so it will be 6b, and so a plus b, that is equal to 6b. Take b to this side, so 6b minus b will be 5b, and therefore a is equal to 5b. Let this be equation number 1. Now we will take these two equations, or the first and third, either one you can take. So take first and the third, so that will be for a plus b upon 3, that is equal to 5a plus 2b plus 1 upon 14. Now cross multiply, so it will be 14a plus 14b, which is equal to, multiply by 3 to this side, and so it will be 3 5s are 15a plus 3 2s are 6b plus 3 1s are 3. Now here 15a and this is 14a. So that if you take 14a to this side, that will be minus 14a, and so 15a minus 14a, that will be a. If you take 6b to this side, 6b to this side, that will be minus 6b. So 14 minus 6, that will be 8b. And this plus b will be as it is. Sorry, plus 3. So this plus 3 will be as it is. Now we know that a is equal to 5b. So put the value of a as 5b. So from 1, we will get it as 8b, which is equal to 5b plus 3. Take 5b to this side, so 8b plus minus 5b, that will be 3b, which is equal to 3. 3 ones are 3, 3 ones are 3, so b is equal to 1. Highlight this value of b, as we have got b is equal to 1. Now we have to find the value of a. So put the value of b in equation number 1. So put in equation 1. So if you put this in equation number 1, so you will get a is equal to 5 into 1, that is 5. So the value of a is equal to 5, and at the end write the answer. The required values are a is equal to 5 and b is equal to 1. Friends, today we will stop here. I hope you must have enjoyed this video. If yes, please like the video, share it with your friends so that they too will get connected with us, and please do not forget to subscribe the channel. Thank you very much for watching this video.